Hello everyone. Today we're going to look into the Airbus A320's air conditioning system. Here's a quick disclaimer. Please pause the video and read it. And let's get started. Purpose of the air conditioning system. The air conditioning system manages the aircraft's cabin environment, which is the temperature and airflow, to ensure passenger comfort and safety. Now, let's get started. I don't want to go too deep into this because it's pretty self-explanatory. You need air conditioning because the A320 flies at very high altitudes where the temperatures are very low and the oxygen is very less. And also into places that are really hot and cold, and we as humans want an appropriate temperature for our comfort, and more important than comfort is our safety. Anyways, this is not too relevant. Moving on. The air conditioning system. Now, you need air to provide air conditioning. Where do you get that air from? From three sources. Number one is your engine, number two is your APU, and number three is your external ground power unit. Some important points before we move forward. Only one bleed source supplies at a given time. Two sources are and should never be mixed. Meaning, if you have a ground card connected, do not switch on APU bleed because, as you know, only one bleed source should supply at one time. If you mix ground and APU bleed, it's going to cause damages inside the system. Now, this bleed air is very hot and high pressure air because it's coming from the engines. Now, before this can be used for the cabin, it must be cooled and regulated. Now, how does this cooling and regulation happen? This happens inside the packs. What are the packs? The packs are the heart of your system. This is a pack diagram right here. There are two air conditioning packs on the A320. They are both operated automatically and independently. There are three things that we control, there are three or four main components. Let's look at them one by one. Now, pack operation is controlled by either pack controller or the air conditioning system controller. Each pack includes a flow control valve. This is your flow control valve, which controls the amount of airflow into the pack, a heat exchanger, an air cycle machine, which cools the air by compression and expansion, and a water extractor, which removes moisture from the air. Now, hot engine bleed comes over here to the heat exchanger, cools down, goes to the air cycle machine, gets cooled further by expansion, and then goes to a water extractor that removes the moisture. So what do you get? From hot engine air, you get cold and dry air, which is at a controlled pressure. You know, the pressure is also reduced because you have expanded the specific air. The engine delivers compressed high pressure hot air. Moving forward, so the green line is basically your hot engine air, which has entered into your packs. Now, the packs have cooled the air, which is going up, and then there are trim air valves. By the way, the green line once again is your hot engine air. The trim air valves still further add hot air into these to adjust the temperature, because just like how you cannot give just hot air inside the cabin and burn everyone off, you can't just throw in very cold air and make everyone freeze. So you balance it by adjusting the amount of hot air that you add to the cold air delivered by the packs. Now, let's talk about the zones and temperature control. There are three zones: the cockpit, the forward cabin, and the aft cabin. The temperature controlled is achieved by three rotatory selector knobs. These are located on the overhead panel in the cockpit. Now, in the 12 o'clock position, the reference temperature is 24 degrees Celsius. Now, if you move one line here, it's -2, so 24 minus 2, 22, 20, and 18. Likewise, 24 plus 2, 26, 28, and 30. So you get a range between 18 and 30 for all the three zones. Now, this is the temperatures that the cockpit crew can select. Now, let's assume the cockpit is very busy and the passengers are complaining that it's very cold or hot. The crew will not disturb the cockpit crew. The cabin crew can modify them through another panel located on the FAP, the flight attendant panel. However, they have a very limited authority of plus or minus 2.5 degrees centigrade. So assuming the forward cabin is set at 24 degrees, and the passenger wants it to be cooler, the crew can reduce it by negative 2.5. So 24 minus 2.5 is 21.5 degrees. I hope that's clear. It's pretty self-explanatory. We'll get into the other switches on the overhead panel in a bit. Now, pack flow control valve. They're talking about this thing, the pack flow control valve. Now, this thing is electrically controlled from the cockpit and pneumatically operated, as you can see, pneumatically operated and electrically controlled. It regulates airflow in accordance with signals received from the pack controllers. Now, if there is no air pressure, for example, if your engine is not running or the APU is off and there's no ground cart, a spring's gonna keep this valve closed. So it's spring loaded to be closed. Now, there are some situations when it's automatically gonna close, when your pack will overheat, when you start the engines, or when you operate the fire or the ditching push button. It's gonna close the valve automatically. The emergency ram air. Let me show you. The emergency ram air. This is your emergency ram air from the diagram. We'll get into it once again. The emergency ram air. This is the button on the overhead panel. The emergency ram air ventilates the cockpit and cabin to remove smoke. If you have a lot of smoke in the cabin, you can just press this button on. Or when both of your packs fail, you have nothing to supply the air conditioning system, correct? Because your packs have failed. Then the emergency ram air flap is going to open and put some air inside the cabin. Now, this is controlled by the ram air push button on the panel, However, do not press this switch if your differential pressure between the cabin and the outside ambient pressure is not less than 1 psi. It should always be less than 1 psi to switch it on. Also, it's only going to open 50% provided it is under automatic control. If it's under manual control, it's not going to open. Moving on. This is just a quick diagram. We'll get into it soon. Now, there's a hot air pressure regulating valve. This valve regulates the pressure of hot air tapped upstream of the packs. Now, upstream of the packs is your hot air manifold. Now, if there's a lot of pressure, it's going to open and release the pressure. Or if there's too less pressure, it's going to open and add the pressure. Now, this is pneumatically operated and electrically controlled from the hot air push button. Pneumatically operated, as per the pressure requirement, it's going to open or close. And electrically controlled from this button right here from the air conditioning panel. Now, it's automatically going to close in 3 situations. When your duct overheats, when your cockpit trim air valve, when this valve will fail, or if both the cabin trim air valves fail, as in the forward as well as the aft. However, they will remain operative if only the forward or only the cabin air valve is going to fail. Now let's talk about trim air valves. As you can see, they basically just add hot air into the cold air from the packs. These valves are also electrically controlled by the zone controller. A trim air valve associated with each zone adjusts the temperature by adding hot air. Once again, you add hot air and adjust the temperature. Now, the cockpit trim air valve is controlled by the ACSC1. By the way, ACSC is your air conditioning system controller. There's 2 of them. The number 1 controls the cockpit and the number 2 controls the cabin. Now there's a mixer unit. This unit mixes cold fresh air from the packs with the cabin air recirculated. It's also connected to the emergency ram air inlet. Now this is your mixing unit. Now this is your cabin air, which is already there inside the cabin, passing through a filter to get cleaned and then thrown from the cabin into the mixing unit with the recirculation fan. And in the mixing unit, you get the mixture of the recirculated cabin air and the cold pack air. Now, if your packs are inoperative, emergency ram air. And that's pretty much it. Now, temperature regulation. How does it happen? It's automatic, all right? It's automatic and it's controlled by 1 zone controller and 2 pack controllers. It's automatic and it's done by 1 zone controller and 2 pack controllers. Now, the zone controller, think of it like the brain of your system. It decides whether I should make the things colder or hotter based on the actual temperature and the requested temperature. Now, ignore whatever is written, all right? Let's assume the current temperature in the cockpit is 30 degrees, okay? And the cockpit crew have selected 24. So the actual is 30 and the selected is 24. So the zone controller is going to think, oh, I need to put more cold air inside the cockpit. So it's going to tell the pack controller to increase the pack flow, make it high. So, more cold air goes up. And it's also going to tell the trim air valves to close slightly, so less hot air goes. This results in a colder temperature being supplied in the cockpit. I hope that's clear. You get it? Now, pack flow can be crew selected, but the system automatically increases the flow. As I said, if you have selected low, but you require more cold temperature, it's automatically going to go to normal or high. Now, irrespective of whatever you select, in 2 cases, the system is going to deliver high flow, basically 120% flow. When one pack has failed or is simply switched off in single pack operation, or whenever your APU is supplying the bleed air. Why? Because in normal operations, you have 2 engines which supply 2 packs. There is, however, only 1 APU in the A320, so you have only 1 source, so it should automatically be high to meet the demands. So this was about the zone controller. Now, what are your pack controllers? Pack controllers are things which actually make them cold or hot. The zone controller tells them. It just tells them, I want cold, I want hot. The pack controllers actually do the work. So this is the brain and this is the muscle. The brain will say, okay, I want to lift this thing. And the muscles are actually going to go and lift. So I actually want a cold temperature in the cockpit. All right, sir, I'm going to deliver more cold air from the packs to the cockpit. I hope that's clear. Now, once again, how does it work? It works with the demand from the zone controller by modulating the bypass valve and the ram air inlet flaps. This is your ram air inlet flap, okay? Now, a quick note relevant for your exam. The ram air inlet flaps are going to close during takeoff and landing. Why? To avoid getting foreign debris inside. During takeoff, they close as soon as you set your takeoff thrust, flex or toga, and as soon as your landing gears are compressed, the main landing gear. Now, during landing, they're going to remain closed until your struts are compressed and until 20 seconds after you have gone below 70 knots. Now, the pack controller also regulates flow by modulating the associated pack flow control valve. Now, if you want high flow, it's going to automatically open this pack flow control valve to a high setting. I hope that's clear. Moving forward. Temperature regulation. We already discussed about it, but just once again, please don't get bored. Zone controller regulates the temperature of the 2 cabin zones and the cockpit. If ACSCs are operating, number 2 is for the cabins and number 1 is for the cockpit. Once again, zone controllers calculates the temperature between the selected and the actual, as I explained previously. And they can further be adjusted from the flight attendant panel by plus or minus 2.5 degrees Celsius. However, one thing to note, a signal corresponding to the lowest demanded zone temperature goes to the pack controller. Now there's 3 zones. Imagine people in the forward cabin are from North Pole and they want very cold temperature. In the cockpit, I am South Asian, so I want hot temperature, so I'm going to set 24. In the aft, once again, South Asians, they want hot, so 24. The forward cabin's full of polar bears, so they want cold temperature. So we have selected 18 over here. The pack controller is going to supply the lowest temperature. So if 18 was selected, 18 is going to go from here. But isn't that bad? Because everyone's going to get very cold, correct? No, it's not. Because your trim air valve is further going to add hot air and give you the requested temperature. That is the function of the trim air valve. So the pack's going to deliver the lowest requested temperature of the 3, and then the trim air valves will adjust the temperatures as requested. Now, let's talk about zone controller. Your zone controller has 2 channels, primary and secondary. Just like the name says, primary is more important. If primary fails, the secondary is going to operate as a backup. However, the flow setting and temperature regulations are unavailable. The hot air and trim air valves are also going to close. The zones are controlled to 24 degrees in your backup mode, and pack 1's for the cockpit, pack 2's for the forward and aft cabin. And alternate mode appears on the ECAM conditioning page. Now I'm going to make a separate video for the conditioning and bleed page where I explain various faults and indications. So please stick on to it for that. Now, if secondary fails, once again, secondary is not that important. It's not going to have any effect. Just that you lose the backup. Now, if both of them fail, optimized, your primary, as well as the backup, your secondary modes are lost. The packs will give a fixed temperature, 20 degrees for pack 1 in the cockpit and 10 degrees for pack 2 in the two cabins. Failure is going to remove all the information on the conditioning page, and then it's going to display pack reg. Now pack controller also has two channels, primary, secondary. If primary fails, secondary is going to go as backup. Regulation will not be optimized and pack flow is fixed. Now, let's assume you selected high pack flow, all right? And then your primary channel failed. Now, even if you select low pack flow, it's gonna get stuck to the prior setting, to high. I hope that's clear. It's a very simple explanation that I could give. Next, if secondary fails, once again, no effect. You just lose the backup mode and some ECAM signals relating to the corresponding packs are lost. Now, if both of these channels fail, how do you control it? Yeah, if both of them have failed, how are you even going to control the temperature? Then the temperature is controlled by the anti-ice valves, and it is stabilized between 5 and 30 between 6 minutes. However, all the ECAM signals related to the packs are lost. Moving forward. Now I told you have two ACSCs. If one fails, the other operates as backup. However, if both fail, the related pack is lost and hot air pressure regulating valve and the valves related to that controller are going to close. Now, if your trim air valve fails, then the temperature regulation of that zone is lost, correct? I'll show you the diagram once again. If your trim air valve is going to fail, then the temperature for that specific zone is going to be lost. If hot air pressure regulating valve fails, now it can fail in two positions, all right? It can either fail open or it can either fail closed. If it fails open, there's no problem. However, if it fails closed, the optimized regulation is lost. The trim air valves are also going to close. Now, if they close, then temperature regulation is also going to be lost. And then pack 1 is going to control the cockpit and pack 2 is going to control the cabin. And all of these are going to go to an average values of the three selected temperatures. So if it fails closed, it's going to close the trim air valves, which is going to make you lose the temperature regulation and give you an average temperature of the three things. Also, pack 1 is going to give the cockpit and pack 2 is going to give your cabin. Now, this is your overhead panel. Let's talk about it in detail now. The pack flow switch over here controls the pack flow valve. Now this is electrically controlled in the cockpit and pneumatically operated inside the pack. Now this is your pack switch. If it's dark, it's on. If it's off is going to illuminate in white. If it's fault, it's going to come in amber. Once again, I'm going to show you a detailed version of it in the simulator. And then you have the three rotatory selectors for the cockpit, forward cabin, and aft cabin. This is your hot air switch. And then this is your engine 1 bleed, which goes to the packs. This is your APU bleed, which goes to the packs. This is your cross bleed. If you close it, nothing from here can go here. For example, if you're using APU bleed, APU should supply both the packs. But if you close the cross bleed, the APU cannot go to pack 2. It's only going to supply pack 1. Now this is your ram air switch. It's a guarded switch, and it should only be pressed when your differential pressure is less than 1 psi. And it's going to open about 50% if under automatic operation. If under manual operation, you have to manually open it. And that's pretty much it. I'll see you in part 2 from the cockpit and show you various fault lights and various problems that are going to happen if various things fail. Now, we already discussed a few of them, like the zone controller. What happens if zone controllers primary, secondary, or both fail for the pack, and then for the valves. The further fault lights will be discussed in the next video from the simulator. Stay tuned for part 2 and have a nice day, guys.